Okay, hello everyone. So in the last video, we kind of gained some intuition that if you want to define local maxima or minima, that the thing we should do is look for when is the derivative equal to zero or when is the derivative undefined, because that's where we're finding that we get maxes or mins at places where there's either the derivative is zero or undefined, right? So here's an example. Find the coordinates, like the exact coordinates of the local maxima and minima for this function y of x is 1/3 x cubed minus 9x. So if our intuition's right, we should take the derivative and set that equal to 0 and solve, and that'll tell us the x coordinate of the local max or min. So I take the derivative of that, and I think I get x squared minus 9, which of course factors as x minus 3 and x plus 3. And I'm going to set that equal to 0 and solve. So I'll get x equals +3 or x equals -3. Okay, so without looking at the graph, I know that those are the coordinates of my possible local max or mins. And then I guess the next question is, are they local maxes or are they local mins? Well, one thing we could do is just plug these values back into the original function. So take these values and stick them back in to find the y coordinates. So let's just do that. So y of 3 is going to be, I don't know what that was doing, 1/3 3 cubed minus 9 times 3. So what's that? That's 9 minus 27, so that's -18. So I guess so I know that now I have one extrema that's 3, -18. And if I plug -3 into y, I'm going to get 1/3 -3 cubed minus 9 times -3. So this time I get -9 plus 27. So that's +18. Okay, so what have I found? I have -3, +18 is one coordinate, and 3, -18 is the other coordinate. So the max or min refers to the y value. So this would be a min, and that would be a max. And I guess we could kind of sketch what's going on here. When I get to -3, I have a max of 3, -18. Sorry, -3, +18. There's a max. And then I go down, and then at +3, I have a min of -18. So the graph looks something like that. And I gave you the exact coordinates. Another way of checking this is to kind of do a number line. Sorry, let me move this down. Another thing we could do is do a number line and keep track of when is the derivative positive or negative. So I know that -3 and +3 are kind of my critical points, or critical points because they're points of interest. That's where the derivative was 0 at those 2 points. And so then what I could do is just plug in points to the left or right and figure out if the derivative is positive or negative on either side. So if I plug in like any point over here, like maybe -4, then what happens? I get, well, let's see, y prime of -4 would be -4 squared minus 9. And so what does that tell me? That's 16 minus 9, so that's a positive number. That's +7, okay? So that tells me that the derivative, y prime, is greater than 0. It's positive, okay? And so that means that the slope is positive. That means the function, the original function, is increasing. So that's what I'm seeing here. The slopes are positive. If I plug in any point in the middle, like 0 is an easy one, I'm going to get that y prime of 0 is -9, so that's negative. So y prime is negative, that means the slope is going down. We see that here. And then if I plug in a point over here, 4 is easy, I'm also getting a positive number. So y prime of 4 is 16 minus 9 is 7. That's positive as well. So that's telling me the slope is going up. So my sketch is good. So this is a way of figuring out, without actually graphing the function, a lot of information. It tells you where the possible local mins and maxes are. Those are the possible critical points. And then also it tells you whether the function's increasing, or the slope is positive, or it's decreasing, and then it's increasing. And so that's what we're going to be doing in this section, is doing lots of gaining intuition about the graph by taking derivatives and looking at when they're positive and negative. The last thing I wanted to say is that while it is true that you can have a local max or min when the derivative is 0 or undefined, it's also possible that you don't have a max or min, you have no extrema. So these two pictures are kind of really important to keep in mind, that sometimes the derivative could be 0, and the function, instead of going back down, it just levels off for a second and then keeps increasing. So you need to get a max or a min here. Or the derivative could be undefined because it's a vertical slope or something, right? And then you don't get a max or min because rather than coming back down here, it keeps on increasing. So this picture I just wanted to highlight, it's from the textbook. It's really important to keep in mind because this is really all the possible cases about local max and mins. If the derivative is equal to 0, it could be a max or a min. If it's undefined, it could be a max or a min. Or it could do something like this, where it levels off for just 1 second and then takes back off. Okay, thank you for your time. I hope this was helpful.